Hi all, welcome back to the studio. I was going to try to finish the motor case temperature sensor thing today, but unfortunately I tried to go to work today and disaster struck. So I was biking to work, having just left my apartment. I was going down my residential street at a nice easy 25 miles per hour when I hear a loud noise from the back and my acceleration stopped. Normally this means that the chain has fallen off the main gear sprocket and is about to get wedged into the main axle, causing me to totally wipe out. But this time it wasn't just that. I'll show you the blinking LEDs on the motor controller that show that it thinks it's doing something. It's all plugged in, so if this isn't actually broken, it's going to kill me. But actually, I've made a mistake. It's been on full throttle this whole time, but that's good. Bad, good, bad. Well, it's sure blinking a lot, but it's not driving the motor any. And really, that was the important part. I definitely know that one of the spec sheets rated it up to at least 26 or maybe 28 volts, but a separate one had it at only slightly above 12, and we may have gone over that. Either way, we have a new toy to take apart. Plus, I wanted to make my own motor controller anyway, so I figured this is a good excuse. It's too bad the motor didn't die though. I would have been able to convince myself to buy a more powerful one. Here's the problem in full color. Let me turn on the bike. This is with throttle full off. It's reading -3 volts. And you can see the motor controller is a solid orange, which should mean neutral, completely neutral, 0 volts. And if we turn up the throttle, you can actually see it goes back down to 0 volts. This is full throttle, throttle at 0. So if I slowly engage, it goes closer to 0, then it comes back on again. And then now here at full throttle, we're only getting up to 6 volts, but that doesn't even drive the motor at all. So obviously something's wrong inside. I have everything plugged into a Y cable, so now both the motor and the scope are plugged in. So we'll see the behavior of the motor controller output when it's actually trying to put out some load. Right off the bat, actually it's at 0 volts. That's correct. So maybe it was only reading that weird -3 number because I didn't have anything plugged in. I might just be totally wrong about all of this. Let me put on some throttle. I can hear a high-pitched noise, but it's just staying at 0 volts. And that's both typical and unfortunate. The motor controller is the most expensive part of this project. It was like 90 bucks, and it's got like fancy features. It's got, current sensing. It's got I was going to try to get all of that working, but then it broke, so... And there's no signs of damage from the outside. You can't see any magic smoke. But one of the reasons I purchased this motor controller is because it's completely sealed. It says that it's not supposed to be rated for continuous use, just like the rest of the bike. But I've felt it during and after long runs, and it doesn't get anywhere near as hot as the motor itself. And it has its own internal current limiting. It'll put out 60 amps continuous, but it'll kill you after 100 amps for 2 seconds. So it's like it's got the smarts to prevent itself from burning up. I've got this held on both by zip ties and by double stick tape. Usually the double stick tape holds on better than this anyway. Came off real easy. I guess it's our lucky evening to an unlucky day. Speaking of which, it's not Friday. Man, that sucks. So we're back at the dissection section of my studio. And it really kind of sucks that it failed today, because this was going to be my second full week of commuting exclusively on the bike, and I had to carry her back to the studio and then drive over. It's actually kind of interesting how little time it takes you to get used to not driving compared to the expectation that you get up and get into your car every single morning. Anyway, let's see how this actually gets put together. There looks to be screw holes in here. I'd show you the inside. I don't have, oh, I have my flashlight on my pants. That's great. I couldn't even see down in there, so I don't know what type of screw that is. We'll just have to stick various tools down the hole and see what she says. Let the games begin. The first contender is a 332s. 332s Allen wrench. It's the same size as the set screws in the gear, and that doesn't work. It doesn't feel like it's going to go at all, so I bet it's some safety here, like riveted. Oh, actually this fits perfectly. You can feel the resistance. They added some thread locker to the inside of this thread, and that's good. So the obvious thing that would have failed would have been a MOSFET, because that's what's taking most of your force. So yep, that's blue Loctite. I know you can't really see that very well. Over on this side we can see, actually this is a really tight board. Got a little double stick thermal paste on top of a big capacitor. I suppose that's supposed to spread heat out here. You can see the stickiness marking where it actually does make contact with that, so that's good. And it all comes in here. It's nicely retained by the outside of this aluminum and then soldered in to prevent it from getting any vibration wear on this solder joint. Here's a better view of the board, at least for you. Let me find something to poke at it with. So this is a reversible motor controller. You can go forward or reverse. And that necessitates, I believe it necessitates four MOSFETs in order to get both directions. You can see there's 4 here, and these are right next to the output leads, so you know they're just going straight to the motor. On first blush, I actually can't see anything wrong with this, which is really weird. Maybe this chip looks a little different from the rest, if these are supposed to be the same. It's possible that this could be partially melted off. I don't know if you can, I know you couldn't see that. But this chip is very, very slightly offset from the rest, from the pads. Or if this had come from the factory like this, in this dead state, I might suspect that this chip was actually contacting the wrong pads. We haven't seen the backside of her yet. There's probably at least an LED for the top LEDs and inputs for the sensors. But overall, this board is really nicely designed, at least, to have this really small form factor. They must have heat sinking on the back to deal with the heat, but it's mostly well put together, as long as this thing isn't actually failed. We've got the heat spreader off, and we can tell it's not really a heat spreader. There's no real active components like the MOSFETs on the other side of the board. We do have some microcontrollers. Looks like 2 plus some crystal thing. What I think I know about these motor controllers is the inputs are supposed to be optically isolated from the rest of the board, because this whole thing runs at, well, should be 12, I guess, volts, whereas your inputs will be 5 volts. And you'd really hate to break your central processor if you wired the motor controller incorrectly. So I'd expect there to be an opto-isolator somewhere around here. It might be these two. And I've been looking at this off camera trying to figure out what went wrong, and I realized that I actually can't see some of these features myself with my bare eye. It's just so closely laid out, so miniaturized. It's really nice. But I'll tell you what, why don't we take this and head over to the microscope lab. So we've got the craptacular microscope set up. So let's take a look at what we can see. So right off the bat, that is not something you'd like to see out of your critical piece of current carrying capability. So I'm going to check the continuity on those. There was one more test I could have done, which was if only one of these MOSFETs had blown or was incorrect, it might have a different functionality if it was going in forward or reverse, is we can recode the bicycle to go both forward and reverse, or we can just reverse the output, have it be a reverse going bicycle, and we can see if it works better, if it works worse, or if it has a sort of constant amount that it's off. I have my test leads set to continuity, so you'll hear the beep as well as I. Let's see how it goes. So that's continuous across all four things on that side. The only possible thing is if I'm just an idiot and these two are shorted inside the chip itself. You know, like, I don't know how this works. And I don't think this is exactly our correct part number, but it is kind of close. Logic level MOSFET. But the important thing we're looking at is we're hoping that this is the correct form factor. The tiny little display here makes me think it is. That looks exactly like what we have. So we can see whether all of those pins on our board are supposed to be the way they are. So let's look at the pin information. And we can see there's 4 pins, it's the same as us, plus on the base of her is actually the, what is it, the gate? No, it's the drain, the MB here. And what this MOSFET or MOSFET lookalike does is when it sees current on, or when it sees voltage on pin 4 on the gate, then it'll allow current to go through the source to the drain. So if on our chip, the gate 4, pin 4, the gate is connected to this source, well, there's no, obviously it's going to be wrong. And that explains why all of the voltages were off by this 5-ish volts. We were getting weird negative volts, getting weird voltage when we had no power at all. It just makes sense that the gate is being erroneously shoved into this MOSFET. Oh, hang on, no, I found it. Full part number is PSMN1R030YLD. It just has a different marking code, a shorter one, so it can actually fit on the package. This is the one that was rated for 300 amps at 30 volts. So that's very good. That's an excellent MOSFET. I hadn't thought that this was possible at all, but I guess online I've seen some reports of like PC motherboard MOSFETs. If you overclock your PC, your MOSFET gets so hot that it just melts right off and falls off the board. I would have thought it was too obvious for these MOSFETs to overheat, that in the design they would be heat sunk enough to not just melt the solder right off the board. But actually looking at my disassembly video for the second time, I realized these MOSFETs, there actually wasn't any heat dissipation on this front side, directly on the MOSFETs. There was one huge layer all the way across the backside, which would have gotten some of this passed through the chip. But I'd expect if you're putting a MOSFET in a sealed enclosure that you'd directly connect the MOSFETs to the enclosure to use as a heatsink. But I knew that this controller wasn't rated for continuous current, continuous use. So at the end of every run, I always put my fingers on every component on the bike to try to figure out what's overheating, what do I need to upgrade. And so that's why I knew the motor was way overheating for what it was spec'd for. But everything else, including this motor controller, was barely warm. But there's no way to tell whether any of these MOSFETs are getting too hot because they don't actually heat sink to the enclosure. You can't feel this and tell how hot it is inside. We are going to try to fix this because this isn't actually broken too badly, we can get these 3 source pins soldered up, no problem. They're already still on there. We just need to separate out the gate pin from the source, and I bet this thing will still work. But yeah, I bet we'll be able to fix this. So stay tuned for a part 2 video.